Today, we're going to make a payment intermediator. Okay, we're going to have an API that will receive a request for users for payments, and you have to intermediate it and send it to a provider. You have n providers. Let's start with 2. And the first one will have the priority. Fine, the first one will be the number 1 of priority. And the second one should have only be called when the first one is not available. Fine. So you have to make this verification to send to the first provider, and in case it's not available, send to the second provider. Fine. This is the main request here. The other request is that both our providers have rate limiting. You can decide which going to be, which number is going to be, but both of them have rate limiting, both for sending the request for payments or health checks, things like that. You can process things synchronous or asynchronous. It's up to you. You decide in your solution what's better. But the payment process should not be lost. Okay, I said process payments, and I try and I can get a payment at the time, and I lose it. I have to make like an outbox pattern or something like that because I can't lose this. Fine. I think that's it. Let us see. It's quite simple. Not a lot of requirements here, but I think we can do cool stuff here. Starting from the point that we're like a startup, we should try to make it as simple as possible and to not spend a lot of money on it. So we can start with a solution that handles it, and after that we can improve it to more users and things like that. Do you have any questions for it?
I do have some questions, but let me share my screen first. Okay, so I took some notes here on the requirements. Let me check if there is anything missing. So we're building here a payment intermediator. We will have multiple providers that our intermediator will connect to. The goal is to have a priority for the first provider. Maybe we can call it the default one. So default. And if not, we can fall back to the second provider that we can call like fallback 1, and maybe other providers that we have in our solution. You mentioned that both providers will have a rate limiting. We can choose async or async architecture, and we have a requirement here for payments to not be lost. And we are keeping a startup in mind and being mindful on what we choose here on our solution. Is there anything missing?
No, that's it. Perfect. Startup is the first part, and after that we can increase to having infinite money and make another solution. But the first one is a startup.
Okay.
Everything
Awesome.
that after that.
And my first question: who will be the client of our solution? Will it be other microservices from our startup? Will it be like real users? Will it be like a load testing?
I think that can be another API.
Okay.
Right? You can use REST or gRPC, anything you want, but it will be another API.
Okay. And thinking that this is a payment intermediator, we need to keep in mind the payment consistency. Will the providers handle the consistency, or do we need our own database to do that?
Yeah,
or we should just be a proxy for the providers?
Yeah, I think we have to have our own database. We don't have to make a complex database because we have to handle this consistency of, okay, I've got this request and this request was failed or success, and I have to make that consistent to the user. Fine.
So if we send a request to the first provider, we need to make sure that the provider accepted the request and it's being processed. And we need to make sure that it's saved in our database to have a consistency between both systems, right?
Yeah.
Okay, awesome. I do not have any other questions. We can maybe start to scratch some things here, and then we can see if some other questions show up to understand. And I can assume that these providers work with a REST API. Okay.
Yeah.
So we have here our default, our fallback, and we could have other providers here. Let me just put that here so we can see. So let's say provider N here. So if we are considering that we need to choose between the providers, we will receive an HTTP request here from the client. We could use a REST API here. HTTP would be the protocol, or payment intermediator will need to have an algorithm. And here I didn't represent it a load balancer, but we could have like multiple containers for our payment intermediator to handle multiple requests. And in that, we will have the connection with all the providers as expected using also the HTTP protocol. I'm thinking here that our payment intermediator it needs to have an algorithm to choose between the providers. So we could choose based on the latency. We could choose based on the status code of the requests. Is there any requirement in that direction, or I can take some assumptions here?
Yeah, you can take the assumptions. The main algorithm is okay. Provider one is always chosen, but if it's not returning any like health check or something like that, then you can choose at whatever other provider you decide based on this fallback decision is up to you if you're gonna make by latency or things like that, or don't know.
Sure.
Anything like that.
So we always choose the default in our algorithm here in our API. And let's consider that this will have like at least 2 containers. So we have at least 2 containers running in an infrastructure with a load balancer, have everything here. We always choose the default. And I'm thinking here that we can have a circuit breaker strategy. So we have a circuit breaker strategy to see if we are sending requests for payment provider 1, and for some reason we are not getting a 200 code status because we are having maybe a network problem, maybe is an infrastructure problem here related to the provider, then we could apply an algorithm to handle a circuit break strategy. So when the circuit is closed, we will like process on the fault. And when the circuit is open, meaning that we have a failure on the default, we could here handle this with a queue to retry on the other endpoints, but it's something that we shouldn't just leave in memory. It's a good idea to have some kind of queue. So I will say here, like add to the queue. And adding to the queue, we could have workers processing on the fallback or any other provider, or even on the default if for some reason we have the circuit open. So here I added close, open, we added to the queue. So here we need something to represent our database. So let me add here. The database, we could choose a NoSQL database or a relational database. I'm considering here that this is a key value kind of data that we will get. Is there any requirement in that?
No, you can use whatever you want. I think it's a quite simple solution, so you can use key store on no relational database, no problem.
Yeah, I agree that a MongoDB here will be a great solution given the nature of the data. So we will have when a payment, what I have in mind. Do you have any other requirements here I should consider?
No, not for this one. Let's keep on this RabbitMQ that you added there, will you use a RabbitMQ that you from your own deploy, or do you think about a managed RabbitMQ from somewhere? What do you think it's better for this case? What you'd rather to use? What solution, like, that AWS has a lot of built-in solutions that sometimes are good, sometimes are not so good. So what do you think about it?
I do think that I'm not sure if AWS has an offering on RabbitMQ, but if it does, I wouldn't use. It's not the kind of thing I would trust on AWS. But if we are using like a SQS from AWS that is a queue that has disk persistence, then it's a great solution because we have high availability between multiple availability zones. That means that if we have a failure in one data center, the queue would still work because you have replication between multiple data centers. So usually SQS would be a good choice if we want to use AWS offering. If not, I would be more tempted to have two RabbitMQ instance, so a master here that we could use to process all the requests. And if for some reason we have a failure, like in this first AZ, we could have a replica here in the other AZ to handle that. It would be like a RabbitMQ fallback that would have some kind of replication between the containers to handle in case of a failure. It's a good approach. We could drift to a managed solution, but usually this kind of managed solution, AWS is not so good as SQS. So handling this in our cluster with a master and a slave to replicate things would be a good approach.
Yeah, I think so. I think that's fine. Now let's think a little bit about the security of that as the company is growing.
The asynchronous processing with circuit breaker, but we could try to fall back to some kind of queue here depending on the event, but this does make sense to be splitted. So you have RabbitMQ to only handle the circuit breaker and this only for domain-driven events that we are dispatching. So I'm quite comfortable with it.
Yeah, I think so. I think that's fine. I think that solution is pretty good. The main thing on this call was about explanation and confidence of explaining things. I think that's perfect too. I think it's really good. It's an example for others to how to make a system design explanation. And the technical parts are perfect too. It shows really well the stuff in there. And DBOF and the API gateway part and whitelist, that are things that not all people know about this, right? Normally people know about load balance, API gateways, and things like that, but DBOF is a more hidden feature that not anyone who knows, and I think this is pretty fine. I think the explanation and the technical part is really okay, and I think this was a really good system design interview, and I think you would pass.
Good to know.
Yeah.
Let's talk about
That's it.
compensation.
Yeah. That's it. I think. Is there someone who wants to ask something or give some feedback or?